Okay, recording. Okay, so I might be your tutorial not so good, especially for the first question. So the first question is actually asking you whether a function whether a relation is a function or is not a function, and you need to prove it. So I realized that I didn't explain that in my notes because I assumed that you already knew that. So let's begin from that. I am sorry, I forgot to recap on this guy. Okay, my note started from if f inverse exists. All right. So let's begin from here. It's a flow chart. So before that, let's look at an example of a function. So here is f of x. It's equal to x squared plus 2x minus 3, for example. This guy here is what we call the rule. And then here I said, comma, x more than or equals to 1. X more than equals to 1 is the domain. Yeah, am I still connected, Ken?
Can, I'm hearing you.
Good, okay. Then just shout into the mic if you cannot hear me. Okay, continuing on. So domain can also be represented as capital D of f equals to 1, infinity. So you start from 1, then you have a square bracket. Then for the range, it will be RF, it will go from 0 to infinity. This one you can draw a graph and you can check. The graph will look something like, if I'm not wrong, here, something like this. Okay, but take note that this is the entire graph if it goes all the way from minus infinity to positive infinity. But here I restricted it to more than or equals to 1. So what should I do to my graph? I should actually chop off the left half. Okay, don't need to draw the left half. But here I put equals to 1. So what happens over here? 1, 0. What should I draw here?
The black dot.
Correct. Circle straight in. Okay, straight in means it's a filled circle, you include that point. Okay, so the graph goes all the way to the right. Then you can see the all the points. Look at all of their x, y. You realize the smallest y is 0, largest y is infinity. So 0, infinity. You include 0 because here is an included circle, a black dot. So you put a square bracket. For infinity, you cannot include it, so you put a round bracket. Can? Sorry, can you give me like 1 minute?
Okay, no problem.
Sorry, yeah.
Okay.
Okay, sorry. Yeah, back. Okay, so yeah, this is how our function looks. Yeah, y equal to f of x with a domain, and you have a range. Okay, so now let's take a look at this flowchart. What I've written over here. I start off with y equal f of x is a relation. So what is a relation? A relation is the more general form of a function. It's basically any kind of equation that relates a x to a y, some kind of relationship. Okay, there are many kinds of relationship you've seen before. Hyperbola, like x, I don't know, x, or maybe ellipse, just to make it easy. X squared over 2 squared plus y squared over 3 squared equals to 1. Right? This is a relationship. But is it a function? We have to check. So what are the two conditions that we need to check? So here's the procedure, checking if f, a function, exists. The first question you need to ask yourself, is this function f, sorry, I shouldn't say function, yeah, I don't know whether it's a function yet, so I should say relation. Is the relation f defined for all values of x an element of the domain of f? In other words, you're trying to look out for whether there are any values of x inside the domain such that the function becomes undefined. This will usually be true, huh? Then you don't need to check. But for question 1 in the EJC tutorial, it is testing you on this concept. There are some special examples where this is no longer always true. Then if your answer to this question is a no, straight away it's not a function. Okay. Whereas if it's a yes, you need to continue asking a second question. You must pass 2 questions, then you can qualify to be a function. The second question to ask is the relation f, does it pass the vertical line test? If you pass, you're a function. If you don't pass, you're not a function. So usually this guy here is usually a yes. So we are in this path. And then from here, it's yes or no. Is it clear so far?
Yep.
Okay.
Yep,
So that is if a function f exists. Okay. Next, we're gonna move on. Well, yeah. Also, if f is not a function already, it is no longer relevant to discuss whether f is 1-to-1, whether f inverse exists, or whether the composite fg exists. Basically, everything related to f, f inverse fg, we don't talk about it anymore. Okay. Good. Can. So if f is a function, then we can if f instead is a function, then there are a few things we can check. We can check its f inverse, we can check its fg, composite function. That's assuming there's another function g. So if f inverse exists, just recap again, you know this from last week. First thing you need to check is f itself is a function. We have already done it using the flowchart above. Flowchart above. I'll just show the flowchart. This guy, these 2 questions. Answer yes for both questions. Then the next one is to let y equals to k, where k is a generic letter, not a specific example, an element of the R of f, range of f. And you say that it cuts y equal f of x once only. Only one time. Then this implies that y equal f of x passes the vertical line test. Okay. So sorry. Oh, sorry. No, this should be horizontal. Sorry, horizontal line test. Then this conclusion is that f is 1, 1. So this step 2 is really just the procedure to prove that the function f is a 1-to-1 function. Then for step 3, you have to conclude therefore f inverse exists. Okay, can. Good. Next, you want to check if fg exists, composite. What do? Remember the Pac-Man. Okay, this is your x. That's your, let's say, inner function g of x. Then that's your outer function f of x. So we need to remember that the range of the inner is a subset of the domain of the outer function. Yeah. So in this case, will be Rg subset of df, imply that fg exists. Of course, if I swap the statement around, I want to show that gf exists. It means that I need to show. It actually goes in both directions. Range of f subset of domain of g. Okay. Can? Can. Okay, good. Now I'm gonna do many practice questions with you. Oh wait, also one more thing to recap. Finding the range. A few steps. First step, draw the y equal f of x graph. You either use a GC or you do it yourself from building up from easier functions. You have learned how to do that in graphical transformations already. I'll go through it later. Then step 2, you want to sketch the y equal f of x. So what's the difference? Okay, maybe this one I don't say draw. This one I say use GC and plot. Okay. Oh yeah, by the way, I will send you the file later. So if you cannot take down in time, it's fine. The PDF. Yeah. Then step 2, you want to sketch y equal f of x for a certain domain. Okay. Happy face less than x less than happy face. Sometimes there's equal, sometimes there isn't. Sometimes there's equal, sometimes there isn't on either sides. Yeah. So sketch this guy with respect to the domain. What does that mean? It means you look at your graph in the GC, but you still need to restrict the graph to within the domain df. Okay. So just like the previous example here, your GC shows you the entire curve, but my domain tells you x more than equals to 1. So you only draw for me the right half. Oh, yeah, I'm sure you know this. Okay, moving on. Step 3, you want to look at all the points x, y. Then after that, you focus on which one? The y coordinate, this guy here, of all the x and y, x, y. Then after that, step 4, you need to identify who is your smallest y, your largest y, and then you conclude. What's the conclusion? RF, the range of f, equals to smallest y, largest y. And then there's a question mark on the left and question mark on the right. What do you put on the question mark? It's either round bracket, square bracket, or round bracket, square bracket, open, close. So this will be determined based on the sketch of the graph. And usually I would ask the student to either identify asymptote, empty circle, white circle, or filled circle, black circle. This will help you to identify whether you should put round bracket or square bracket. If it's a round bracket, square. For the other two cases, round. Or if it's infinity plus minus, also round. Maybe I should make it like this. Can based on your graph. Are we clear on that?
Can.
Okay, not clear, then we will do lots and lots of practices. 20 examples on finding the range of functions. Where let's just assume that the function exists, you don't need to prove it. So I prepared this beforehand because I see your question not so well done. So I prepared many examples. We'll just go through them all one by one before I discuss your tutorial. Okay, so let's take a look. Example 1, you got fx equal to x squared minus 8x. So of course you can straight away use a GC to draw it. I also gave the domain to be x, an element of all real numbers, so you can just copy from the GC. This is also equal to x times x minus 8. So you can draw it manually. X minus 0, x minus 8 means 0 and 8 are the roots. Positive x squared, so it's a happy face. And then the turning point is the average of 0 and 8, so it's a 4, x equal to 4. Sub in x equal to 4, you get a negative 16 for the y. So this is a point, which is the which has a smallest y, negative 16. Then how about other points that contain largest y? You look at all the other points. You realize that actually the graph goes all the way to the left and the right, to the left and to the right. So that means that they will have a y coordinate that is positive infinity. Agree? Essentially, largest y is positive infinity. So that means that your range of f, right, will be smallest y, largest y. So minus 16, infinity. Then which one do you put round bracket, square bracket? Here, this point, is it included? Is x equal to 4 part of x an element of all real numbers?
Yes.
Yes, correct. So that means that this point is included. You draw a circle, you shade it in. In your tutorial attempt, I saw that you drew a circle and you never shade in. Or maybe it's because your handwriting too small, I cannot see. Yeah, so that might have been a little bit of a misconception. Do you understand why I shade in now?
Yeah, I do.
Yes, okay, so you shade in because x equals to 4 is part of the domain. That means this point is included, which also means that this smallest y is included, which means that it should be a square bracket. Then for infinity, round bracket. Can? Understand this, RF?
Yeah, can.
Okay, next one. We're gonna go for another example. Minus x squared plus 8x minus 16. Can you see how they are related? X squared minus 8x to minus x squared plus 8x minus 16.
Yeah, the thing, the graph bring down by minus 16.
No, more something else. Positive x squared become minus x squared. Minus 8x become plus 8x.
The graph change, like flip over.
About the which axis?
X-axis.
Exactly, correct. So just to save some time, you can see the pattern. You realize that you just need to know this pattern. Fx equal d plus c times f of bx plus a. You always follow the transformations in terms of a, then b. You do a first, then b, then c, then d. So in other words, A first and B means you are changing the x. Change x. Change with respect to the x direction. Change in x direction. X direction. And C and D is change in the y direction. Okay. Specifically, when you have a plus A, it means that you are translating or translate by minus A units in the, I don't know, it depends. Let's assume that A, let's assume A is more than 0. So you are translating by minus A units in the negative y direction. Sorry, negative x direction. Okay. Then for the B, multiply to the x, that means that you are scaling the graph f of x by a scale factor of 1 over b in the, sorry, not in the, parallel to the x direction. Then how about plus c and plus d? Okay, I'll just draw it over here. The plus c here, when you multiply it to the f, it means that you do the, you're changing the y, you're scaling by a scale factor of, this time it's not 1 over b, it's just c. Don't need to 1 over anymore. Just c parallel to not the x direction, but rather the y direction. Okay, graphical transformation, one more plus d would be translate in positive d direction. Okay, let's just assume that d is positive as well. If it's negative, then you will just go in the opposite direction. Assume d more than 0. So that means that you'll translate by, instead of minus a, it should be plus d units in the, instead of negative x, it will be positive y. Okay, so that's basically all you need to know about graphical transformations in this format. So over here you see that there's a minus sign, right? It actually means you have to reflect. Okay, maybe I forgot to mention one more point. If c is negative, we reflect about x-axis. Yeah, and likewise, if b is negative, reflect about the, not the x-axis, but rather the, which axis?
Y-axis.
Y-axis, exactly. Okay, good. So now we can look at this and then we just draw the graph. Basically, it will look something like, you reflect it first, right, from the original graph. So that means we end up with a shape like this. This is y equal minus x squared minus 8x. Upside down. But then after that, you transform it a bit more. Transform a bit more, and then you shift it down by 16 units. So to save space, I'm going to move my x-axis upwards by positive 16 units instead. So the turning point there was a 4, negative 16. So if I flip it upside down, this point here is actually 4, positive 16. If I shift it down by 16 units, it means I'll touch the x-intercept. I'll touch the x-axis, get an x-intercept here at 4, 0, and then I will have a set face. Okay? Can?
Can.
Now tell me, what's the range of this new function?
Square bracket 4, negative infinity round bracket.
Wrong. Do you know why? Follow the procedure. Do you remember the procedure?
Yeah, sorry. Round bracket negative 4, 4 square bracket.
Yes, correct. Smallest y, negative infinity is the smallest, okay? Actually still wrong. Not 4. Focus on x
Oh,
or y.
0, 0, sorry.
0. You made that mistake in the tutorial as well. You put in negative infinity on the right side and then you focus on the x coordinate, which is totally wrong. Okay, so are we clear on this part now?
Yeah.
Can Okay, let's move on to the next example. This one, logarithm graph. I got 20 examples to clear, so I need to go a little bit faster. Okay, so the log x minus 1 base half, how do you draw the graph? First thing to remember is I have no idea what happens when the base is a fraction, except that I know I need to do some graphical transform, need to do some logarithm tricks. So do you remember the change of base formula? Change of base formula?
The one you're doing right now, right?
Yes.
Yeah,
So
I
basically I'll
remember.
just write. Good. So that means that what I'm about to do here is I'll pick a base that is like a positive number more than 1. So let's just say, for example, 10 now. Of course, a nicer, faster way to write this would simply be LG base 10 will be just LG. Then after that, yeah, that's base 10, right? LG is base 10. Then here, what you realize is that LG of half is just a number. Or rather, you can think of it as 1 over LG of half, which you can key into a calculator. It's some number. It's being multiplied to LG x minus 1. So graphical transformation tells you what? Means you should start with a LGX. I hope you can see that. Then after that, you transform into y equals LG, I don't know, x minus 1. Then you transform again, you scale it by this factor of 1 over LG half times LG x minus 1. Right, let's just call it A, let's call it B. I need more space. Then I'll say A will be translate by 1 unit in which direction? Can you tell me?
I cannot really remember this concept, but I think it's like positive x direction.
Correct. Good. Very simple one. You see minus here for the x, right? Remember A, B, C, D. There's always the change in x direction and change in y direction. For the change in x direction, this one is very confusing. Why? Because let's go to the example. Here, okay. Here. It's confusing. Why? Because here you got minus 1. So you would think, minus, isn't it to the left? Right? Should be to the left. But actually, unfortunately, because of how the function is written, when you have a minus 1, the x will have to work harder. Right? The minus 1 is like pulling the grade down. You minus 1 mark. So the x has to work harder. You can think of it like that. If x has to work harder, that means you have to become more positive, a bigger score. So that's why you move in a positive x direction. It's a bit counterintuitive. Or you use reverse psychology. You got minus 1, then you must work harder. Somebody pulling you down, you must push harder. So it become moving in a positive x direction. Likewise with the scaling, if you recall what I've written here, you scale by a scale factor of 1 over b. If it's times b here, you need to flip around. Very weird, very funny. For the x direction, it's always a bit funny. You see positive, but end up become negative direction. You see a b, end up becomes a 1 over b. So just remember that. Change in x, change in, sorry. Did I not change the letter here? Sorry, I meant to write a y here. Change in x, change in y. Which one more confusing? X is more confusing. Okay, can I don't spend too much time talking about graphical transformation. I'll just carry on with this transformation. Then A will be translated by 1 unit in positive x direction. Then B, here's how I present it. I draw arrow, put a capital letter, A, B, then I describe at the bottom, A dot dot B dot dot. So in this case will be what? Scale by scale factor of in the, or is it parallel to? Can you fill in the blank?
Factor half.
Look carefully. Here is your fx, right? Sort of. And then you have a c in front. So for C, what's the pattern? Do you need to flip it, or you just copy the entire thing?
Just copy the entire
So that means that it's scale factor of 1 over LG half. Can you quickly type in a calculator for me what is 1 over LG half?
thing. Negative 3.3219.
Yeah, so the decimals don't really matter. The emphasis here should be the -3. What happens when there's a negative?
Your thing flip over.
Yes, correct. So maybe just to be a little bit more precise, right? We should account for the fact that it's negative. And then I'll just make a small comment over here. Since 1 over LG half is negative, we need to reflect about x-axis. Okay, then so should it be in the or parallel to?
In the.
Oh no, something multiplied by a function. C, right? C multiplied by a function.
Oh wait, sorry, parallel.
Parallel to, so yeah, you need to go and work on your graphical transformation as well. Parallel to which direction?
Y direction.
Yes, y direction. So you scale it up. So that means that eventually, how does the graph look? Let's just work it out step by step. So first you have y equals lgx. I hope the screen is not too small.
It's fine.
You pass through 1, 0, then transform it with operation A. Then you end up with lgx minus 1. Minus 1 tells you to move to the right by 1 unit. So what will we get? We'll get this graph instead. By the way, did you know that there's a vertical asymptote here? Previously it was x equal
Yeah,
to
I
0.
know.
Now it's x equal to 1. Good. So what's the new point here? X-intercept, the new x-intercept.
2,0.
Very good. Then after that, we transform by b. So now b tells you what? B tells you have to essentially flip it around because of the minus sign, minus 3.3 something something. The minus tells you need to flip it upside down. The 3 just tells you what? You need to scale it up, make it thinner. If you want to do as b part 1, like you flip it around first, then you will get something like this. 0.2. B part 1 means you flip, because or in other words, B part 1, I should be more precise. It means you multiply by a -1. Then B part 2, you multiply by the 3.3219, which means that you will essentially make it steeper. So honestly, the graph doesn't change. You see, these two graphs, there's not much difference. Okay? You don't need to split into B1 and B2. You can just jump directly to operation B. This LGX minus 1 graph transforms under operation B into this new resulting graph. This is 2, 0. Okay, that's how you get a graph. Can? Without a GC. Can, good. Now tell me, I have the domain being all real numbers. Wow, this is getting quite messy. I did not plan to talk about graphical transformation so much. Let me just adjust my notes a little bit to make it look neater. Yeah, I'm gonna shrink it down. Here, I'll shrink it down as well. This will be a PDF, so you can just zoom in and look at it eventually. Yeah. So what if, let's say, the domain here, oh no, the left half. If let's say that the domain here is all real numbers, oh sorry, actually shouldn't be all real numbers, should be more than 1, then what will be the range? Look at this graph. What is the range?
Negative infinity, positive infinity.
Well done. Exactly. Good. It goes all the way up, all the way down. Okay. Or in other words, just set of all real numbers. Take note that this is the set of all real numbers. You draw R and then you draw an extra vertical line. It is different from RF. This is range of F. Can?
Yeah.
Okay, good. Next. Okay, next one, ln x plus 3. How to draw the graph? Without a GC. ln x is like this. Asymptote x equal to 0. This one 1, 0. Of course, x equals 0 is just a y-axis. This is y equal ln x. But that's not what we want. We want to have y equals to ln x plus 3. Plus 3 means what? Move right or left?
Move left.
Ah, very good. So move left, then that means we'll get this graph instead. What's the vertical asymptote now?
-3.
Good. Then what is the x-intercept now? Is it still 1, 0?
-2, 0.
Very good. Okay. Then now tell me if x is more than -3, what's the range again? Domain x more than -3, what's the range? Does it touch you?
No, it doesn't.
No. So your graph should be more precise. You don't try to touch it, just try to make it like almost parallel lines already. Almost parallel lines at the bottom. Okay. Don't let it intersect. Yeah. So what's the range?
Is it also negative infinity, positive infinity?
Exactly. Correct. Good. Okay. Next. Of course, you can also put down all real numbers. Okay. Next example. Sine inverse. Have you seen the sine inverse graph before? Yeah.
Never see before, but like, is it just like the opposite of sine graph?
It is the, what do you call it? Reflection about the.
Oh, y equals x.
Yes, correct. Yeah, it's just a reflection about y equal x. So I already drew it for you to save some time. The domain is -1 less than equal x less than equal to 1 by my design. Then you get these 2 points solid circle. Why do I put solid circle? Because equal sign, equal sign. So what's the range?
Negative square bracket -1, 1 square bracket.
No, just on x or y.
Sorry, -pi/2, then pi/2.
Round or square?
Square.
Solid circle, square. Okay. Go back to the procedure. Remember, what did I say? Smallest, y. Largest, y. Focus on the y. How do I emphasize this? Y coordinate. Don't look at the x. Don't look at the x. Okay? Can focus on the y coordinate. Moving on.
Okay.
Look at the next example. So now we got example 6, fx equals to tangent inverse x. X an element of all real numbers. Have you seen the graph before? Like this. It goes all the way.
No, but
Basically, you know the
reflection.
reflection, exactly. And because the original tangent graph, it goes downwards all the way and upwards all the way. If you reflect it, it becomes rightwards all the way and leftwards all the way. Oh, you get what I'm saying? There's an asymptote here.
Okay.
Previously, if on the original tangent graph, you had x equal pi/2, x equal -pi/2. When you reflect it, it changes to -pi/2 and positive pi/2. So now what's the range?
Round bracket -pi/2, pi/2, round bracket.
Well done. Good. Next example. Can no questions or I'll just move on.
Sorry?
You got it right. Then I'll just move on. Okay.
Okay, sure.
Just let me know if you want to stop. Okay, next one. Fx equal cosine inverse. I drew the graph for you already. Domain -1 less than equal x less than equal to 1. Of course, again, it is just a reflection of the cosine graph, but not really. Because cosine graph actually it looks something like this. If you try to reflect it, what happens? You'll end up with a graph that looks like this shape, but it will be in the negative region. And we don't want that. Let me think a bit. Let me think a bit. Let me. Sorry, let me draw the cosine graph a bit. Okay, let's see what happens if we reflect it. If we reflect it, we will essentially get, this shape first. You rotate 90 degrees and then you reflect. So now you'll end up getting something like this. You see this? Okay, this is my rough working, but this is the resulting cosine inverse if you try to reflect it. Reflect the original y equal to cosine x about y equal to x, correct?
Yeah.
Huh? Then you take a look compared to the graph that I've drawn. You see, if you try to reflect the entire line, right, you'll get an entire snake like this. Does this pass vertical line test?
No.
No, right? Then it's not a function. So that's why we have to restrict the domain so that our cosine inverse, so that our original function f, this is f, sorry, bit confusing with the notation. I mean, original cosine must become 1-to-1. We restrict it we are actually restricting it from 0 to pi. Huh?
Okay. Is it like when it's inverse that time, then the test it becomes like vertical line?
When you are testing whether the cosine inverse function, the inverse function, is or is not a function, then you are using vertical line test.
Okay.
Yeah. So before we even talk about inverse functions, right? This is not a function. You see, because it fails straight away in the vertical line test. What we do is we restrict our domain from 0 to pi of the original function so that we get this part of the curve, the orange color, which means that this orange color part, what do you notice? It is a 1-to-1 function, right? Unlike the original, it's many to one. Is this part clear? 1-to-1?
Yeah.
You draw horizontal line, it only cut one time. So yeah, that it passes horizontal line test, it's 1-to-1. Then if you after you reflect it, which part of the graph is it? It's actually just this part over here. Okay. Then that's really what I've drawn over here. To make sure that this function inverse exists, you must pass vertical line test, which in turn means that the original function must pass the horizontal line test. Because you reflect about the y equal to x. Horizontal becomes vertical. Can? Okay. Can. So now we just look at the graph, then tell me what's the range. Include
square bracket 0, pi square bracket.
Well done. Very good. Finally, look at the correct coordinate. Okay, Ken, moving on. Example 8. Another graph, trigo graph now, sine. For x an element of all real numbers means the graph just keeps on going. What's the range? Keeps going to the left, keeps going to the right. I am distracting you. Range, look at what? X or Y?
Y.
Y,
wait, I forget I key in the calculator.
Yeah, I wrote down for you already.
Oh, sorry. Square bracket -1, 1 square bracket.
Oh, sorry. Yeah, correct. Square bracket -1, +1 square bracket. Well done. Good. Can the cosine graph will always have a maximum and minimum of +1, -1. This one you know already. You should already know this from AMAX secondary school. Okay, how about example 9, cosine x?
Same thing as like the previous one.
Exactly, same thing. Because what you realize is that you see the sine curve, you see the cosine curve, it's really just a translation, right, by 90 degrees or pi over 2. You see, you are just moving leftwards. So that means cosine x is really just, by knowing graphical transformation already, it's just sine x, but you need to move the sine x to the, let me think. You need to move the sine x to the left by 90 degrees by pi over 2 radians. So it's just sine x plus pi over 2. Correct or not?
Yeah.
Can or? Okay, good. Let me think. Yeah, okay, can. Moving on. So example 10, Hendra next. Asymptote, x equal negative pi over 2, positive pi over 2. I gave the domain to be that already. So what's the range?
Round bracket negative infinity, comma infinity round bracket.
Well done. Good. Next one, example 11. 2 power x. X an element of all real numbers. So the entire graph goes to all the way to the left and to the right.
Round bracket 0, comma positive infinity round bracket.
Wrong. Is this the first mistake is you focus on x coordinate instead of y. Wait a minute, hold on. Let me think of it. Oh, sorry, you are correct. I'm sorry, I'm blah blah. Yes, I'm not awake yet. Yes, you are correct.
Okay.
I am so sorry. This graph goes all the way nearer and nearer towards the x-axis, but never touching. So the y coordinate is almost 0, but never touching. So it's round bracket, cannot include 0. And it goes all the way to infinity. Infinity cannot include, so it's round bracket. Yes, you're correct. I'm sorry. Okay. Let's try example 12 now, but it's the same function 2 power x, but x is more than negative 0.5. So I drew the graph for you. Negative 0.5 and 1 over square root 2. I meant to put an equal sign here.
Then it's the same as the previous one, just that like the left hand side is a square bracket 1 over square root 2.
Yeah, comma infinity round bracket. Okay, good. Can next example, let's go. This is example 13. E power x. X an element of all real numbers.
Round bracket 0, comma positive infinity round bracket.
Yep. Okay, good. Next one, example 14. 0.8 power x. Whenever the fraction here, in general, y equals a power x, where 0 less than a less than 1, the graph will just go in the opposite direction. Like instead of going upwards, it goes downwards. Okay, because it's now a fraction.
Okay.
What's the range? Domain is
same as the previous one.
Okay, good. 0 to infinity. Good. Round bracket, make sure you got round bracket. Next one, let's say I now have negative 2 times 0.8 power x. So let's show the previous graph again. Graphical transformation tells you you need to multiply by negative 1 first, then multiply by 2. So let's do that. Multiply by negative 1 first, what happens?
You reflect
about
the x-axis.
Correct. So that means this graph, right? 0, negative 1. Like this. Yeah. But then now you still have an extra times 2. So what happens?
I don't know what's the term. Like I don't know if it translate scale but like you bring down then you scale by negative 2.
Scale by negative 2. If it's bring down, right? Let's say that if it's bring down, it would actually be fx equals to, this is a totally different example. Negative 0.8 power x, and then you bring down, so minus 1. Okay, let's just try the example later. Let's just try and draw that graph later. Let's focus on this simpler example first, this graph. So what's the range?
Round bracket negative infinity 0 round bracket.
Well done. Good. Let's try and draw this graph now. So negative 0.8 power x then minus 1 means you translate downwards by 1 unit, right? So this graph, you're going to translate downwards by 1 unit. So let's just draw a quick sketch of that graph. So what will we get? We'll get something like this. It will still cut through 0, negative 2. But this time, where is my asymptote now? The horizontal asymptote. Previously, it was y equal to 0. After you bring down by 1 unit, where's the horizontal asymptote? Must be over here, right? Also brings down. So it's y equals. What would it be?
-1.
-1, exactly. Just bring down by 1 unit, so -1. Okay, so what's the range?
-∞, -1 round bracket.
Very good. Yes, must change accordingly. It's not always a 0. Sometimes it's -1. Depends on the graph function. So yeah, that's just an extra point. Next example 16. You got fx equals to 2x over 1 plus x squared. So this is a very special function. It's what we call a cubic graph, because if you treat this as if it's equal to y, and also x an element of all real numbers, still domain. If you multiply denominator over, you get y bracket 1 plus x squared. Then you multiply out, what do you get? You'll just end up with this guy here. Y plus x squared y equals to 2x. Over here, what you notice is there's a x squared y, right? It's really just x times y. How many variables do you see? 1, 2, 3. Then we call this in general terms a cubic graph, multi-variable, which is technically not really in your syllables unless it is presented in this format, where it's 2x over x. Everything is in terms of x. For this kind of graph, right, it will always have a very special property, which is that there is an asymptote here. Okay, do you notice the asymptote y equal to 0?
Yeah.
But what happens? Usually you memorize this, right? The asymptote, the graph will never touch the asymptote. But that's actually not true. The technical definition should be asymptote never touches the graph when x approaches infinity or -infinity. Okay, when x approaches a certain limit. In this case, sorry, should be limit point. In this case, what happens is that this graph, for small values of x, in particular x equal to 0, it actually cuts the asymptote. Do you notice that? At 0, 0. So very special, right? Even though it's an asymptote, the graph still intersects the asymptote, but at small values of x. So at small values of x, in this case, x equal to 0. Example, specific to this example, the graph cuts the asymptote. So it's not always true that the graph never cuts the asymptote. I'll just take note of that. Okay, so anyways, looking at this graph, there's a maximum point 1, 1, minimum point -1, -1. So what's the range?
Square bracket -1, 1 square bracket.
Well done. Good. Okay. Next. This one. This is what we call the bell curve. Oh, wait, I forgot to put a domain. This is what we call the bell curve. Fx equals to e power -½ x squared. Bell curve. Have you seen it before? Graded according to a bell curve. You heard of that?
Yeah.
So basically, it's if you take further math, you will learn this. It's called a PDF, probability density function. You will learn this in year 2 of further math. For H2 math, you still need to know this, but what you need to understand is that the area under this graph is very special. It is always exactly equal to 1. And by the way, this graph has an asymptote y equal to 0, so it actually goes on all the way to infinity. Okay? The very funny special thing about this is that the area under the curve, if you try to integrate and you try to solve, you can't solve it. You can't solve it. That's the first funny thing. You need to use a computer or use some sort of numerical approximation approach. And the area under the curve will always be equal to 1. And that is probability. You learned before in secondary school, probability must always be less than or equal to 1 and bigger than equal to 0. But here, what is so special about this curve is that eventually you're going to learn that something like P of x less than 2, this notation, you've never seen it before. It will be next year. X here is what we call the random variable. Then 2 there is like a value. So what this means is it's really just an area underneath the PDF. when you put in x equal to 2, and you consider the area to the left from negative infinity all the way until x equal to 2. This region here, the area, right, is the probability. Okay? If you can catch that, then you will have an advantage next year. But if you cannot catch that, never mind. Let's just look at the graph and figure out what is the range.
Actually, it's the x-axis at asymptote.
Yes, correct. Yes, y equal to 0 is asymptote.
Then round bracket 0, comma, 1 square bracket.
Yes, correct. Oh, by the way, the general form of this bell curve, I better not mislead you. This is a special case of the general formula 1 over square root 2 pi multiplied by our sigma multiplied by e to the power of negative half bracket bracket square. What's inside the bracket? X minus mu over sigma. This is the full-fledged form. You don't need to know this.
Okay.
We replaced the what I did is I replaced the sigma with 1 and the mu with 0. And I got rid of the 1 over square root 2 pi. Yeah. Anyways, moving on. Oh, right, sorry. Actually, this graph technically, area under the curve will not be the probability. I forgot. I need to scale it by a scale factor of 1 over square root 2 pi first. Wait, let me modify this diagram. What I mean is, I don't say blue area is of the other graph. This guy, a more flat version of the original graph. This one is 1 over square root 2 pi. Then you multiply by e power negative half x squared. The blue area would be this region all the way to negative infinity until you reach x equals to 2, which is over here. That is your probability. Okay, if you can catch that, good. If you cannot, it is okay. We will move on. Let me know if you're interested. This is your year 2 topic already. Example 18. Let's see. You have fx equal to x over x plus 1. They tell you that x is an element of all real numbers, x less than negative 1 or x more than negative 1. How can it be? Oh, can. Less than negative 1, more than negative 1. So it means you're excluding negative 1 itself, right? So what's another way to phrase this domain? It's to say x element of all real numbers, but you slash open curly brace, negative 1, close curly brace. This is what we call a set minus. You take the set of all real numbers, you remove away a particular set containing minus 1. So it means you're just removing negative 1 from the all real numbers. Okay, because you cannot include x equal to negative 1. If you sub in x equal to negative 1, what happens to the function?
It becomes horizontal line.
No. Look carefully at the denominator.
Oh wait, infinity.
You get to negative 1 divided by 0. No, not infinity. It's called undefined.
Undefined, I mean.
So if it's undefined, then the function isn't even a function anymore. Which is actually question 1 part A. This is what you're supposed to do in question 1 part A of the EJC tutorial. You're supposed to recognize that the domain includes all real numbers, which the domain is all real numbers, which includes a certain value of x that will make the function undefined. Later, then I explain, it will be quite obvious. Yeah, so this one minus simplify, you do long division, because this is degree 1, so you do long division, you eventually get to quotient minus away, and then minus 1 is the remainder, divide by the divisor. Okay, basically on top goes to the left, remainder goes to the numerator. Is that clear?
Yeah.
Okay, now, yeah, then you get this fraction. Graphical transformation, again, it will be 1 over x first, transform into 1 over x plus 1, then maybe transform into negative 1 over x plus 1, then you add on a 1. Step by step, A, B, C. You can go work it out on your own if you want, but I'll just jump straight to the final result, which is this graph here, okay? Using a GC. Okay, it will pass through 0, 0 as well, coincidentally. So vertical asymptote, take note, is substituting the denominator with 1, right? You know this? This is the topic of
oh yeah, I know.
rational functions. Rational functions. Then the next one will be oblique asymptote. It's just the quotient here, y equal to 1. So how do we derive? Why is it y equal to 1? It's because we are considering what happens as x gets bigger and bigger. As x gets bigger and bigger, what happens to your graph? It approaches 1. So that's why it's the asymptote. But if you want to do it algebraically, we need to introduce this idea known as the limit. You know this idea? You actually need it. You actually needed this idea in your midterm exam.
Yeah, I know.
When it's talking about sequence and series. So the idea here is you want to consider what happens to the graph as x goes to infinity. Algebraically, how we write it is we take limit of the entire expression, 1 minus 1 over x plus 1, as x goes to infinity. Then we can split it up term by term. It's a bit like differentiation, right? A bit like differentiation. Like if you differentiate x squared plus x cubed, you can differentiate x squared first, then you add on differentiate x cubed, derivative of x cubed, right? Term by term. Does that make sense?
Yeah.
Can this is what we call the linear property. Just make sure you understand what's going on term by term. So same thing over here. We got a 1, we got a negative 1 over x plus 1. We can also split it up term by term. But then you sort of distribute the limit. So limit of 1 minus away limit of 1 over x plus 1. You can even factor out the negative 1. Okay. Is this part okay?
Can. Actually, sorry, can you give me a moment? My sister is calling for me.
Can.
Very fast one. Sorry.
No worries.
Okay, I'm back. Sorry.
Okay. Can. Just let me know if you need to go away. It's fine. Yeah.
She just called me.
Okay. Yeah, so limit of 1 as x goes to infinity is 1 affected by x?
Yes.
No, you see 1 is on its own. There's no x involved. So it's just remaining as a 1. Okay, we can simplify this down. We can drop the limit.
Okay.
It just stays as a 1. Okay, but how about here? What happens as x approaches infinity? What does it even mean? This mysterious symbol. Just think of it as substituting the x with bigger and bigger and bigger values. So you start with like 1 over 1 plus 1. Then you change to 1 over 10 plus 1. Then you change to 1 over 100 plus 1, 1,000 plus 1, 10,000 plus 1, 100,000 plus 1. Then you look at the value. What happens? What is it approaching?
0.
Exactly. It will approach 0, right? Eventually, if you go all the way to infinity, the biggest possible number, then you just go to 0, the answer. We say that it is exactly equal to 0. The limit of 1 over x plus 1 as x goes towards infinity, tends towards infinity, approaches, is equal to 0. Or 1 over x plus 1 approaches 0 as x goes to infinity. Another way that you could write this is x arrow infinity, comma, 1 over x plus 1 arrow 0. You should get familiar with this notation as well. Okay?
Okay.
Yeah, then so this becomes 0, then 1 minus 0 is 1. So that's how you get the horizontal oblique asymptote y equal to 1. So now can you tell me what's the range? Maybe this one I should explain a bit because you have never seen it before. So whenever you got you've seen this function definitely, right? But you haven't discussed the range yet, is it?
Sorry?
I think you've seen this kind of function before, right?
Yeah.
Okay, now we talk about how to find the range of this function. So I hope you notice that there's a vertical asymptote here. So it means it goes all the way to negative infinity. So the smallest value must be negative infinity already. And then round bracket around it. But what's the biggest value? You notice that it goes, if you follow this part of this half of the graph, it goes towards 1, right? So it's less than 1. So you would think that probably it's 1, but it's an asymptote, so it never reaches 1, so round bracket. But then you think a bit more and then you realize, but wait, here, it goes all the way to positive infinity. So shouldn't this change to positive infinity?
Then is it like all real numbers then excluding 1?
Exactly. Yes, you have to exclude this one here, right? So that means, yes, you should just be all real numbers excluding one. Another way that we can write this out is the following. Using the interval notation, minus infinity, comma, 1, then round bracket. And then do you remember union notation? Union? O levels? Intersection and union? Like A intersect B? Sorry?
Yeah, I remember. I remember.
Okay, so this is just a different way to represent it. Here, A is like a set. This is the set, minus infinity, comma 1. All the real numbers in between minus 1, negative infinity, and 1. That's the set A. Then now we're going to union it. Okay, I changed this to union to make my life easier. You union it with B, another set B. What would that be? It will be 1 to positive infinity. Okay, so we cleverly avoided the 1 by using the union notation. Okay? That's another way. You may see this in solution books. If you buy like online, whatever assessment book online, or from Popular or whatever, you may see this kind of solution, union notation. So basically negative infinity to 1, then 1 to positive infinity, exclude the 1. Okay, let's go on. Example 19. Okay, we have fx equal to x squared plus x plus 1 divided by x plus 1. So we do long division straight away. So let's just recap. X squared divided by x, what do you get? X. Then x times x plus 1, x squared plus x. Minus bracket, what do you get? 0, 0. Then bring down the 1. Minus nothing, plus 1. Do we continue? Continue or stop?
Stop.
Stop. Yes, 1 is a smaller degree than x already. So therefore, conclusion is this is equal to x plus 1 over x plus 1. How to draw the graph? Straight away, without a GC, you also know, but you can type in the GCs right now as I tell you manually how it works. Y equal to x is an asymptote, right? So that means I have to change this guy into dotted line, broken line. Label it as y equal to x. And since we got a denominator x plus 1, we can equate it to 0. Solve for x, you get negative 1. So we have another vertical asymptote here. I'll change it into a broken line. Then where will the graph be? Okay, maybe just to make my graph look a little bit nicer, I'm going to focus only on the Okay, I'll extend it a bit more. Then I will move this down, make it a bit shorter. Okay, I have an iPad, that's why I can do this. But if you're on paper and pen, you need to use pencil and eraser.
Okay.
Yeah, so this is y equal to x as well as the other x equal negative 1. So where will the graph be? There are only 2 possibilities. It's okay, actually maybe 4 possibilities. It's either this way and this way, this way and this way, this way and this way, or this way and this way. So how do you test it without a calculator? You just need to sub in a particular value. Let's say I want to figure out x equal negative 1 is my how do I say, my boundary to help me to separate. I know that my graph will either be here or there. Can it be both? Can it be both curve?
No.
No, cannot, because you will fail
The vertical line test.
the cactus test, the vertical line test. You draw a vertical line, you will cut 2 times. So it's either here or there. So we can sub in with a value, let's say sub x with something smaller than negative 1. Let's say minus 2. What do we get? We get minus 2 plus 1 over minus 2 plus 1, which is minus 1. That's minus 3. So that means where would my point be? Negative 2, comma negative 3, somewhere here, right? Right?
Yeah.
Okay, this point is actually minus 1 and minus 1. So it's probably somewhere here. But anyways, you know that it is above y equal to x. So that means your curve can only be this guy. Does that make sense? It cannot be here anymore. If it's a curve here, it can't pass through that point. So that means you can draw the sketch now without using GCR. Also, by the way, try to make it approach the asymptote. Then the next curve, it's either here or there. So what should we do? Sub in with x equal. What should we sub in with? Mic test, can you hear me? Uh-oh. Hey. Mic test, can you hear me? I cannot hear you. Am I connected?
Sorry, I was muted.
Oh, okay.
Can you hear you?
Sorry. So you want to figure out the next graph is either here or there. So what should you sub in with to check?
Oh, I know what to sub in.
Not sure what to sub in. Okay,
Yeah.
you see, the graph is either here or there. It's towards the right of x equal -1. Towards the right means the x will be bigger or smaller than -1.
Smaller
To the right, to the right.
or bigger than -1.
So let's say, for example, just I draw a fake curve, maybe something like this, another fake curve, maybe something like this. If let's say I sub in x equal to 0, I will either get here or there, right? Positive or negative, right?
Yeah.
Okay, maybe there's a possibility that the curve when x equal to 0, it could be negative. But yeah, so anyways, the key point is it must either be above y equal to x or below y equal to x. At x equal to 0, it passes through 0, 0, the y equal to x. So if I now sub in x equal to 0, which is bigger than the vertical asymptote x equal -1, vert means vertical, asympt means asymptote. You sub in, what do you get? You get f of 0 equals to 0 plus 1 over 0 plus 1, which is really just 1. Okay, so that means that you pass through 0, 1. Where is it? Over here, right? Here.
Yeah.
So that means your curve must be something like this. But now you need to find turning point. How do you find turning point? It must curve towards the asymptote. So it must be something like this. It must bend towards asymptote. So it must be something like this. It passes through this point. But then there will be a turning point, right, in order to connect them together.
Yeah.
How to find turning point?
Is it close to the asymptote?
Yes. But you can just use a GC, or if you don't want to use GC, how would you do it?
I don't know how to use without GC.
Okay, I tell you, it's basically differentiation. Right?
Okay, I know
turning
already.
point. You know, okay, I don't go through the procedure. So have you found out the turning point? What exactly is it? The coordinates?
Haven't, give me a moment.
Okay. X plus 1 over x plus 1. It's a minimum point.
Yeah.
So I got a -7.792 e power -7. E minus 7, which is times 10 power -7, which is essentially just a 0, okay? And then the y is 1. So that means that actually this point here itself is our turning point. That's not always the case, by the way.
Oh, okay, I get it.
The turning point may be to the left or to the right. Okay, so now that we have the graph, can you tell me what's the range? Let's say that the x is an element of all real numbers. df equals to all real numbers except for -1. What's the range?
Negative infinity, positive infinity, then exclude -1.
Wrong. Here. Let me think. No. You see, the range is all the way here, from -infinity to infinity. Then how about here? It's from 1 to infinity. When we take the union of two regions, we actually take the largest region. Does it make sense?
Yeah.
So it should actually just still be minus infinity to positive infinity. Don't need to exclude a 1. We're focusing on the y. You look at all the points available
Okay.
and you focus on the y coordinate. Yeah, then smallest is
Okay.
minus infinity, biggest positive infinity. Clear?
Yeah.
Okay, don't need to exclude. Okay, example 20, last one. Okay, 3x squared minus 2x over x minus 1, x minus 8. So I'll just save you the trouble. I gave you the graph already. So there's an asymptote y equals to 3, x equal 1, x equal to 8. Tell me what's the range. This is this one a bit special notation. I'm using x an element of all real numbers, remove away 1 and 8. Because here got x equal to 1, x equal to 8. I want to remove it. So that's my domain. Or a funnier way to write it would be minus infinity, comma 1, round bracket, then union with round bracket again, 1, comma 8, then round bracket again, union, round bracket again, 8, comma infinity. Why do I put round bracket? Because I want to avoid the 1 and avoid the 8.
Okay.
So what's the range?
I'm not sure if I should put in I'm not sure that I should like exclude y equals 3 or not, because like the left hand side and right hand side never touch 3, but like there's a intersect at like y equals 3.
Okay. So here, when you want to find the range, you're including at the moment you pass through y equal to 3 at least one time, you have to include already. Okay, because range is really just a set containing all the possible y values. And 3 hits, you hit 3 here, right? You notice that? Yeah, so that means 3 is inside the set. So no, you don't exclude the 3.
Okay.
So what's the range?
Then negative infinity, positive infinity.
Wrong. You know why? Notice over here, turning point 0.429 comma negative 0.071. Here is 1.491 comma negative 1.54. Negative 0.071 is maybe this line over here. I draw in red. And y equals to negative 1. Okay, let me get rid of this. Y equals to negative 1.154 is at the bottom like this. Agree so far?
Yeah.
So that means that over here, what do you notice? There's nothing here. No graph here. So these values are not allowed. Okay? So what should it be? It should be element from negative infinity to positive infinity, or you can simply write it as set of all real numbers, but you remove away this region here. But you need to you cannot include these two values. These two values, they actually hit it. So we should remove the interval from open bracket negative 0.0. Oh, sorry, small to big. So it should be 1.154 comma negative 0.071. Does that make sense?
Yeah.
All the real numbers except for these guys. Okay, based on the graph. Okay, good. Another way to phrase this would be, let's say in the union notation, it will be negative infinity all the way to negative 1.154. Then union with negative 0.071 comma positive infinity.
Okay.
From here to here, then from there to there. You skip. Okay, you have a gap. You have a gap, then you have the union. Okay, that is 20. Yay, good. So now I actually prepared 7 more examples on finding out whether the following relation is or is not a function. I'm gonna go through it. I have to go through it because this is the basics. I think if you do the tutorial without the basics are a bit too difficult. I should have started with this maybe. Okay, examples. First example, y equal f of x equals to square root of x, x an element of all real numbers. Is this a function? So look back at the flow chart here. I took a screenshot. This is a H2 Max student. He's thinking, okay, check if f exists or not. Or rather whether f, the relation is a function or not. So you're using this procedure. First question you ask yourself is it defined for all values of x an element of d of f? What does that mean? It means you want to look at all the x values. Here, x an element of all real numbers. Wow, so many possibilities. But really, when you say all real numbers, there's only 3 possibilities, okay? What are the 3 possibilities?
Negative infinity, 0, positive infinity.
Not just infinity, just something negative, something positive. Okay. Trichotomy of numbers, negative, 0, or positive. If you intend to study math in university, you should know this. But if not, never mind. Just but for now, you need to know there are negative numbers involved, right? Correct or not? Negative numbers are involved, part of the real numbers. So what if I let x equals to -1? That's reasonable, right? Because it's inside the domain. So what happens to my f of -1? Square root -1.
Not possible.
Is undefined, or rather, for real numbers, if you try, have you tried keying in square root -1 before on your GC?
I cannot.
Try. What did they tell you? Error?
Error syntax.
Syntax? That doesn't seem right. Wait a minute. It should be non-real numbers. Okay, wait. What I meant is, hold on a second. Let me share the screen. Let me share my GC. Share GC. Can you see? Can you see the GC?
Yeah.
So what I wanted you to type is square root -1. Enter. Error, non-real answers. Next year, you will learn complex numbers. Okay. Square root -1 is actually I. You get something very funny, like if you find the letter I here, it's at the decimal point, and then you raise it to the power of 2. It's actually equal to -1. Isn't that funny? I square is negative. How can a square number be negative?
Yeah.
It doesn't make sense, right? You'll learn this complex numbers, very complex. Not really, But anyways, moving on back to the question. Yeah, basically you need to know that square root -1 is undefined if you are talking about real numbers. Okay, so we just say that f -1 is undefined. Okay, this is getting a bit crowded, so I'm gonna remove all this. I'll just say includes negative. You say let x equal -1 an element of the domain, and then you check f of -1 equals square root -1 is undefined. You don't need to say for real numbers, just say undefined. And therefore, f is not a function.
Okay.
Can?
Okay.
Good. Moving on. Next one. Question example 2. Can you tell me, is that relation a function?
If it's defined, then if it passed like the vertical line test, then yeah.
Yes. So in this case, I wrote down for you already. This guy is defined. For first step, is it defined for all values of x? Usually it's a yes. You don't need to explain. If it's a yes, you don't need to show it. If it's not true, then you must give me a specific counter example, right? Counter example, like x equal -1. One particular example where this function doesn't work. Okay, can understand the counter example idea?
Yeah.
Okay, for this one, you already know that it is defined, so that means the first question it's a yes. Now you must check, does it pass the vertical line test? So how do you phrase the vertical line test? Here's how you do it. First, you draw the graph, x squared minus 6x. That's just x times x minus 6. So 0 and 6, happy face. Then you must draw a vertical line, let's say here. Take note, it must be a generic vertical line. Let's call it x equal to k. We'll say, since x equals to k, an element of df, which is from -1 to 5 excluding. So maybe my graph, I should refine it a little bit. It should be starting from -1 here, inclusive. So it's -1, comma, let me see, -1 square minus 6 times -1. What would that be? 1 plus 6. So 7. And then when x equal to 5, what is it? It's 5 square minus 6 times 5, which is 25 minus 30. Hold on. 25 minus 30, -5. Right. Okay. Then my graph should actually be something like this. Can you see?
Yep. Can see.
Can. Okay. Yeah, so over here, this is the graph. Then we need to draw a vertical line. And then we need to call it x equal to k, an element of domain of f. And we say cuts graph only once. This implies f passes vertical line test.
Wait, is it vertical line or is it horizontal line? Because like I'm kind of confused.
Okay.
Whether it's vertical or horizontal.
You must read the question. Here, the question is asking you, is the following relation a function? So it's asking you about the existence. Is it a function or is it not a function? I didn't say inverse. I didn't say inverse. The question here, I said is or is not a function.
Wait, so if it's like function is vertical line, not horizontal line?
Correct, yes.
That
Yes.
means like my tutorial I do like all the line wrong already.
Yes, that's why. Yes.
Oh.
Yeah.
Okay, okay.
You are showing that it's one-to-one or not, but that's not the question. They are asking you whether it is or is not a function itself first, before we discuss inverse. Okay, so yeah, passes vertical line test and therefore it is a function. F is a function. Okay, can example 2 done. Let's go on to example 3. So let me zoom out and show you all the questions I want. Yeah, so it's formatted like this. Question, then I say sketch, and then essay or explanation. So let's just fill in this table. So example 3. I hope it's not too small. Can see.
Can see.
Yeah. Okay, is the following relation a function? Y equals to sin x an element of all real numbers. Now the first half, you need to ask yourself is, are there any values of x inside here such that if you sub in, you'll get a value that's undefined? Yes, no, don't have.
Don't have.
Don't have, then you can just ignore it. Don't even bother explaining. Now the next question to ask is, does it pass the vertical line test?
No.
Vertical means up, down. Vertical line
Wait,
is
sorry, yes. It
yes.
passes.
So the procedure to do that, right, is first you must have a picture inside your head, which means what I labeled here, sketch the graph for x an element of all real numbers. So like this, and just keeps on going forever. I'm not going to draw everything. Then after that, you must write the essay or the explanation for this. So what I do is I draw a random vertical line. It doesn't really matter where it is, as long as it's inside the domain. So you can say that since x equal to k, an element of domain of f being all real numbers, cuts graph of y equal f of x only once. This means f passes vertical line test. Yeah, so basically it's the same essay again and again, a bit like econs.
Okay.
So f is a function. Okay, next one, example 4. Is the following relation a function? So x more than equal to 2, right? So we should probably start with a sketch, right?
Yeah. Hold on, I'm keying in right now.
Yes. Okay, I will do it manually.
Yeah, it's a function.
Yes, good. But then you need to explain it. So this one is let me see, -8. So more than or equals to 2, right? More than or equals to 2 is a domain. So that means I should start from here and move to the right. So let me draw the diagram again. Circle, shade in. Why did I shade in? Because
More than equals to.
correct. Then you draw the curve. Okay, so what else do you draw? Do you draw vertical line or horizontal line?
Draw vertical line.
Vertical line. Okay, good. So that means I'll draw this over here. X equals to, again, I call it K. You can pick any other letter you like, but this is how I like to write it. So I write it again. You realize it's exactly the same explanation. Since X equals to K is an element of the domain of F, in this case, domain of F, is it still real numbers? No, it's more than or equals to 2. So you should write down 2, infinity, square bracket, round bracket. Cuts graph of y equal fx. Oh, by the way, I didn't label f of x over here, so please let me off. Understand that this is f of x.
Yeah.
Understand?
Yeah.
If I call this g, then you have to change accordingly, okay?
Okay.
G of x, then this is dg, and then y equals g of x. Graph of y equals g of x only once implies that g passes the vertical line test, which implies that g is a function. Okay, that's example 4. Okay, next, example 5. Yes or no, function or not? First, we should draw the graph. You realize y square, I cannot key in. The GC only got y1, y2, y3. I cannot y1 square, y2 square, y3 square. So what do you need to do?
Square root the x.
But remember, square root must involve a plus minus.
Okay.
Okay?
That is, it's a function.
Nope, wrong. It is not a function. Here, when you have plus minus, you need to consider both graphs now. This is the positive square root x. That is the negative square root x. When they ask you for x more than or equals to 0, both graphs are acceptable, right?
Yeah.
So draw a solid circle here.
Okay, I get it.
Draw a vertical line. You get it. So it's the same essay again. I'm just gonna copy and paste now.
Sure.
And then I modify. Since x equal to k, an element of D, I'll call this f to be more standard. What's the domain? More than equals 0. So I change this 2 to a 0. Cuts the graph of y equals. If I call this, okay, maybe in this case I can't really label it as f of x anymore. So does it make sense? I'll call this f of x comma y, but it's a bit confusing. Never mind. I'll just call it f of x as usual. Yeah, f of x cuts the y equal f of x graph only once. This means that g instead of g should be f passes, or not passes. It should be fails the vertical line test. Then f is not a function. Let me read again. Since x equal to k, an element of df, domain of f, equals to 0 to infinity, cuts the graph of y equal f of x only once. Oh, that's wrong. Sorry, I shouldn't use a generic letter k anymore when I'm trying to come up with a counter example. You need a concrete example. So let's just say x equals to 1. When you're coming up with a counter example, you use a specific example to be a strong case. When you are trying to prove it in general, you should use a generic letter. Is that okay?
Okay.
This part I need to be careful. Must be a specific letter. Specific number, sorry. Okay, next example. What is it? What did I plan for? 2 more examples. Okay, so let's recap on what is the conical sections. So circle, ellipse, and hyperbola. I drew for you the different versions already. Circle, ellipse, or hyperbola. Now, let's just recap first. Whenever you want to get equation of circle, ellipse, or parabola, you should look out for x square and y square. And then in front of them, there's some number and a plus minus sign. Okay, you see the 2 question marks? So examples would be like 1x squared plus 1y squared equals to 1. Or 2x squared plus y squared equals to 5. Or 2x squared minus y squared equals to 7. These are the kind of graphs that you should know straight away as circle, ellipse, or parabola. Hyperbola, sorry. Is that clear? Okay, then the key thing to take note is this table. When you have the magnitude, this vertical line is like the magnitude. So we don't care about plus or minus. Just take the value. Just take the positive. The magnitude of coefficient of x squared equals to the magnitude of the coefficient of y squared. If this is true, take means true. Then ellipse, okay, sorry. Let me rephrase it. Here is the column asking the question whether they are equal or not. For circle, it's a yes. For ellipse, it's a no. Hyperbola is a no. Then let's look at the next column. Next column, another property is we are looking at whether the sign of the x squared is the same as the sign of the y squared. In other words, if you look at this example, you'll notice there's a plus plus, so it means it's the same. Plus plus means it's the same. Plus minus means it's different.
Okay.
So here, tick means same, cross means different. Then using this table, you will be able to deduce what is whether an equation is a circle, ellipse, or hyperbola. Okay, moving on. So now let's take a look at this relation. Is this relation a function? X an element of all real numbers, minus 11 less than equal x less than equal to 6. I just gave the answer straight away, but let's just figure out what is this curve first, or what is this relation? Can you tell me what shape is it?
Circle.
Nope. Look at our y square and our x square. Magnitude of coefficient, are they the same or different?
Same.
2 and 1. 2 and 1. Right?
Oh,
2y
sorry,
squared and
different.
1y squared. Different. So can it be a circle? Cannot be a
No.
circle anymore. So it's either ellipse or hyperbola. How do we tell if it's ellipse or hyperbola? We go on to the next column. Is the sign of the x square the same as the sign of y square? Got two options, yes or no?
No. Oh, so it's
Huh?
hyperbola.
No. Look at the plus 2y square and plus x square. Same
Oh,
or
it's the
different?
same. Sorry, I want to see the coefficient of x and y instead of x square y square. I mean, I want to see the sign of x and y instead of x square and y square.
Oh, okay. No. Focus on x square and y square, yeah?
Okay.
So same, right? So therefore it is a?
It's a ellipse.
Ellipse, yes, exactly. Okay, so before you even do any algebra, you will know it is an ellipse. Get familiar with this table. Okay, let's figure out how to simplify this, how to sketch the equation of an ellipse from this graph manually. How we do it is we must do completing the square. Remember that procedure?
Yeah.
Y square with y, x square with x. Then later we bring all the constant to the right hand side. Leave the constant alone. So let's focus on 2y square minus 20y. I like to factor out my coefficient first, so I get a 1y square and then minus 10y. The other one, it's already a coefficient 1, so I leave it alone. Then now factor out the 2, I complete the square. So this becomes y minus 5, 10 divided by 2 is 5. Then bracket square, then minus away 5 square. Add on x square plus 6x. Okay, actually this one can complete the square straight away. It's just x plus 6 divided by 2 is 3. Close the bracket, square, minus away 3 square, equals to 5. Multiply out, you get 2 times y minus 5 bracket square. Then you get 2 times negative 5 square, which is negative 50, plus x plus 3 bracket square minus y 9 equals to 5. So we get 2 times y minus 5 square. We get plus x plus 3 bracket square. What do I do with my constants?
I bring over.
Exactly. Then you get 5 plus 50 plus 9, which is 64. Coincidentally, it is 8 square. Can? Do you want to keep it as 8 square? No, I don't want. Throw it away. Later, then we deal with the 8 square. What I want to do now is I want to make sure that my right hand side is equal to a 1. Okay, make sure that my right hand side is equal to 1. So here it's equals to 64 already. I'm going to divide by 64. Same thing on the left hand side. I'm going to copy the entire thing, but I divide by 64. So I can skip a step. I just split it up straight away into 2 separate fractions. Is this okay? The splitting?
Yeah.
Can then now we want to continue simplifying this. 64 over 64 is just a 1. But here, x plus 3 bracket square is actually just x plus 3 bracket square over 8 square. And then you add on the other guy. 2 and 64 cancel off, you're left with a 32. So it means it's y minus 5 bracket square over square root 32 square. Why did I write it in such a funny way? It's because of the general format of a ellipse. X minus p bracket square over a square plus y minus p, sorry, shouldn't be a p again, should be q. Square over b square equals to 1. It means your center is where? Center is?
A square, p comma q.
Correct. Then the horizontal radius will be?
A square.
Wrong.
A.
Just a. Vertical radius will be?
B.
Just b, exactly. Without the square. That's why I purposely take out the square. On 32, I don't leave it as 32. I write it as square root then square. So I know that my, oh, by the way, take note that the horizontal radius, maybe I can call it the x radius. And then this vertical radius, I call it y. These letters A is directly, how do you remember it as the x radius is because it's directly below the x. Then the B is directly below the y. So from this example, can you tell me what's my x radius and what's my y radius? What's my x radius?
My x radius is 32. Square root 32.
Wrong. When I say x radius, I mean like you have this oval shape. X radius is this part here. And that part there. X. Look carefully at the equation again. It's not just left and right. I swapped it around. The y is now on the left, then the x is on the right. But here, x is on the left, y is on the right.
8.
It should be 8, yes. Then the other guy is square root 32.
Square root 32.
Okay, good. Then how about the center?
Center 3, negative 3, 5.
Very good. How do you get that? You just have to equate to 0. So like x minus p equate to 0, bring the p over. Y minus q equate to 0, bring the q over. Here it's a +3, bring over, become -3. So that's why it's -3. I'll just review the graph straight away. This is how it will look. Okay. I drew it beforehand to save some time. All right. So how do you draw the graph? How I did it was I started off by not drawing the x and y axis. I just draw the center. Then after that, I consider my radius. Then I get my corresponding coordinates. So -3 minus 8, then -3 plus 8. But the y coordinate will be the same. But for the top 2 points, it will just be x coordinate stays the same as -3, but you have to add on the y radius, +32, -32, square root.
Okay.
Yeah, then after that, now that I know this is -3, 5, I bring back my x and y axis. Okay, -3, 5. All right, then now question. Look at the domain. What's the domain? -11 less than equal x less than equal to 6.
Yeah.
So -3 minus 8 is actually -11. -3 plus 8 is 5. 8, is it 5? Yeah, 5. So is this a function?
No.
Why?
Because for the vertical line test, it cuts the curve, it cuts the ellipse more than once.
Exactly. Okay, so a good example of x would be x equal -3. X equal -3. X equal -3 cuts the curve more than once. Implies not a function. Okay, that's all. But here, actually, there's another more subtle point, which is that I change it to less than equal 6, which means that in between 5 and 6, you can also draw a line. But here, what you can say is that if you let x equals to, let's say, 5.5, something that is outside of the graph already, you try to find f, or you try to find the corresponding y. You try to find the corresponding y, f of 5.5. This will be undefined because it's outside of the graph already. So that means that there exists an element in the domain such that f of that element is undefined. Let me show you why this is true. Actually, I don't use 5.5. I use 6 can already. As long as it's something that's beyond this x coordinate of 5. Beyond this 5. Here, it's possible because I have less than equal to 6. So let's just use 6. Okay. F of 6 is undefined. So how do I find the y when x is equal to 6? How I do it is I just have to substitute into my equation, my original equation. So I'm just going to copy down my equation. I'll replace everywhere that I will now replace everywhere that I saw that has an x with 6. So here it becomes a 6, there it becomes a 6, 6 times 6. Let's calculate that. This is 36. This is also 36. Minus 20y, 2y squared equal 5. So I can bring it over, then, okay, I can bring all the constants over. So I eventually get a quadratic like this, 2y squared minus 20y plus 36 minus 5 equals 0. Solving for the, simplifying the constant, I get 67. 2y squared minus 20y plus 67. If you check the discriminant, b squared minus 4ac, what do you get?
Let me key that in.
Remember the discriminant?
Yeah. Negative 136.
Can less than 0. What does it mean when it's less than 0?
Doesn't cut the curve.
Doesn't cut the curve. And in this case, it's a positive coefficient, so it's floating above. It's a happy face, floating above. Okay, so in other words, there is no real solution. So no real solution means what? Means you don't have a corresponding f of 6, which means that this is undefined. Okay?
Okay.
Okay, now that is for the example 6. Now let's move on to the last example. I'm using the exact same equation again. So I'll just copy and paste the working. I'll eventually simplify it back down to an ellipse. But I restricted the domain now to 5. Does it still work? Is it still a function? Does it now turn into a function if I restrict the domain? Now it goes from -11 to 5.
Still, not a function, but it's the same thing.
Yeah, it's still not a function. It doesn't change. Even though the domain got restricted, it is still not a function. Why? Because it still fails vertical line test. So I can copy and paste your reason. Okay, so your reason previously about the x equal -3, cutting the curve twice, therefore it fails vertical line test, it's not a function. That works. But I also gave another alternative reason. But here you have only one possible reason to show that it's not a function. Vertical line cuts it more than once. Okay, 7 examples. And then I actually also planned another 7 examples I want to go through, but I'm running a bit low on time. So maybe I'll just cut short to like 2 examples.
Okay.
Then you can try the rest as practice. Okay, let's look at the first example. Okay, sorry. Let me read the question first. So what is this question? It's asking you, sketch the graph of y equals f of x and y equals g of x. That's your first instruction. Second instruction, does the fg or gf exist? Only one of the two is true. This is a composite function, f of g of x or g of f of x. Now, for the guy that does exist, we want to find that guy's rule, domain, and range. Okay?
Okay.
We want the composite function. The guy means the composite function. Okay, let's look at the first example. So we got f of x equals to -3x plus 1. G of x is square root of x. The corresponding domain is -2 less than x less than equal -1. The corresponding domain is x more than equal 0. Okay? So we draw the graph. Let's take a look. Here, -3x plus 1. Because there is a strictly less than here for -2, that means that over here, if you look at the graph and you draw the graph, it's just -2, 7, but you have to draw empty circle. But here there's an equal sign, so you have to draw a solid circle. Is the graph okay with you?
Yeah.
Okay, now -3x plus 1, that's why it's downward sloping. Plus 1 means it will eventually cut the y-intercept at 1, but I'm just looking at the left half. So what's the domain in terms of the square bracket, round bracket notation?
Domain is round bracket -2, -1 square bracket. Then range is square bracket -1. Square bracket 4, 7 curve bracket.
Very good, much better. Corrected yourself. Focus on the y. Okay, range is always the y. Then the domain is the x. Do you understand the color coding?
Yeah.
Now, purple, light blue. Okay, then let's try g of x, square root of x, x more than equals 0. I drew the graph for you already ahead of time. What's the domain of g? What's the range of g?
Domain is square bracket 0, infinity, close bracket.
Round bracket.
Round bracket. And then the range is The same thing.
Good. Yes, because the range is over here from 0 all the way to infinity. Same thing as domain. Okay, so now we have to check. You either check range is subset of this domain or range is subset of that domain.
Can it be such that like the first one is not possible, but the second one is possible?
Wait. What do you mean? Sorry. What do you
Let's say
mean by
like
first and second?
like GF is not possible, but FG is possible.
FG possible. Oh, did I mix it up?
Oh no,
I
I'm
thought
just
it's
saying. I'm just saying, like in a scenario, can it be such that like GF is possible, but FG is not possible?
yes, have. In fact, yes. That is what is actually I'm trying to replicate the EJC tutorial. Yes, that is what they're asking you. Yes.
Oh, okay.
Only
Because I
one
didn't
of the
know.
two. Yeah. Then
Okay.
for the one that is true, I call it the guy. The guy
Yeah.
that is true, that does exist, you want to find the rule domain range. Okay, so now let's take a look. Which one? RF subset of DG or is it RG subset of DF? Let's check this one first. Is the range of G a subset of DF? The answer is a no.
Yeah.
0 to infinity, is it a subset of -2 to -1?
No.
Definitely not. Positive cannot be part of negative. So that means this is out. So FG does not exist. You must always be inner function here, then outer function. You always check range of inner subset question mark of domain of outer. So here is inner, there is outer. So G is inner, F is outer. You write it as FG. Then you check the other direction. RF subset of DG, is it true? Is this one a subset of that one? 4, square bracket 4, 7 round bracket, is it a subset of 0 to infinity?
Yeah.
Yes. Okay, how do you check it? Let's say you have difficulty visualizing it. What you can do is you can draw a number line. So no space. You can draw a number line like this. Let's say you have a number line here, and then you have a 4, you have a 7, you have a 0. Then for RF, you can represent it like this. 4, so you draw above a 4 a circle, shade it in because it's square bracket. Then all the way to 7, then you draw round bracket. So this will be RF. And then you have DG. What is DG? 0 to infinity. So you draw a square bracket at 0, go all the way to the right. So you end off with an arrow.
Okay.
That's DG. Then you're asking, is this RF inside DG?
Yeah.
Shorter, then therefore definitely inside. Okay, good.
Okay.
Then the other way around, RG not a subset of DF. I'm also gonna draw another number line just to be extra sure that you know what's going on. Range of G, I see 0 and infinity, so I label a 0 and then infinity somewhere here. Then how about the domain of F? It's -2, -1. So I label -2 and -1. So maybe somewhere here is -2, somewhere there is -1. Let's calculate, let's draw out what is RG first. Here, right? 0 to infinity. Then how about DF? It must be here, right? I'll label it. Oh, sorry, this should be. Did I do something wrongly? It should be DG, sorry. Then this should be the range of G. This should be domain of F. Then you can see that range of G is not a subset of domain of F. This guy is not contained inside that guy. Right? They're totally separate. So that's why we say that it's not a subset. I hope this part is clear.
Yeah, it's clear.
Okay, can good. Then therefore this exists, that one does not exist. Now the next part of the question is we want to find the rule, domain, and range of the composite function. So first let's find the rule. So the GF exists, right? So we try to calculate what is G of f of x. In this case, G is square root, f is -3x plus 1. Then that's it, that's our rule. Then what's our domain? D of GF. It's just D of?
D of F.
The inner function. Good. So D of composite equals to domain of the inner function in general. So df is what? Df we already calculated, so just copy down -2, -1 square bracket. Domain done already. How about range? How do you find range of GF? There's two ways to do it. First way is to draw the graph, plot this into your GC, and then you check the graph. But I'm going to show, but that's easy. Yeah. I'm going to show you the more difficult way, which is the manual way, this way. Let's see how we do it. You draw this diagram. You draw this diagram. I drew it ahead of time to save some time. Then D of F, we already know what is it. So let's just fill it in. -2, -1. The inner function is what? F. So we put down F on top of the arrow, and then you get R of F. Then you don't just draw it for fun. You fill in the blank. RF equals to what? RF equals to?
RF equals to square bracket 4, 7 round bracket.
Exactly. Then now you want to find R of GF. How do you do that? What it means, what it means is you now have an outer function G. You put it on top of the arrow. So what we are going to do is we're gonna put this 4, 7 into the function G. You have some machine G here and a conveyor belt, and you're putting in 4, 7 inside. What's gonna come out of the conveyor belt? So that just means your domain of G is now restricted to 4 to 7. Then we can now look at our graph of G. This is G. Then we think 4 here, 7 there. What's the corresponding range? Maybe if I just make my y-axis a bit longer so it's nicer, I will get
the value of y when x equals to 4.
And when x equals to 7. Yes, exactly. Oh, let me try to make it look nice. So yeah, now you have x equal to 7, then the corresponding y value must be square root 7. Because gx is square root x. Yeah, so what's the range? Focus on the x or the y?
Y.
The y.
Square root 4, square root 7.
Include or exclude? Tell me, okay, maybe tell me round. Oh, that was quite loud. Sorry. Just tell me round bracket or square bracket first. Open bracket should be round or square? Round, square? Can see?
Yeah.
Round or square?
I'm not sure.
Not sure. Okay. We look back at here. This 4, 7 is being fed into the function G. It's being fed into the function G. Did you feed in 4? Do you throw a 4 into the G function?
Yeah.
Yes. So that means is square root 4 included?
Yeah.
You put in 4, that means the square root 4 will also be produced. So that means you include square root 4. Include.
Okay.
Maybe it would be nicer if you just draw a solid circle here and an empty circle here. So straight away, you know square root 4 is included. How about square root 7? Is it included? Did you fit in our 7?
Yeah.
No, round bracket. Round bracket means you fit in 6.1, 6.2, 6.8, 6.9, 6.99, but not 7. So no, it should be an empty circle here. Okay? So what do you get? You include square root 4, but you don't include square root 7. Is it clearer now?
Yeah.
So what should it be? Open should be round or square?
Square, then after round.
Very good. Well done. Okay. I have time to spare. Do you need to rush off?
No. But wait, you want until what time?
I am free all the way. My lesson got cancelled. Until 12 or something, whatever. I will not charge extra.
Okay. I think I can maybe until like maybe half an hour more.
Okay, can. Let's go.
Okay,
next example. Let's see. So hold on, I need to sort this a bit. I need more space. Okay, let's take a look at the next example. Example 2. We got fx equals to 0.2 times x minus 1 x plus 4, and then gx equals to x. So let's take a look at this function now. First thing you should do is to sketch the graph. So 0.2 x minus 1 x plus 4. Can you quickly type in the GC and tell me how the graph looks?
Okay. Oh my god, wait, I write wrongly.
0.2
x minus 1 x plus 4. minimum, and then the
Minimum is this one? Yes?
let me calculate. Yeah, but it's like somewhere around the point that you're trying.
Yeah.
Yeah,
Somewhere.
correct.
Somewhere.
Correct.
Roughly.
Yeah, your value is correct.
There is 1, there is -1. This is the graph from your GC, yes?
Yeah.
But wait, x more than equals -1.5 is my restriction on the domain. So what do I do?
Cut off the left hand side.
What do I do over here? Round or solids? White or black?
Black.
Okay, good. Okay, that's your graph. It passes through 1. Okay, that is fx. How about gx? We do the same thing. This one y got x. You don't need a GC for this.
Yeah.
More than -1.25. So that means that you should start the graph from somewhere at the bottom like this. This is -1.25. Y, if x equals -1.25, y will also be -1.25. Solid circle or empty circle?
Empty.
Empty circle. Well done. Okay, so it goes all the way to the right. This is not a vector. This is just a line. Okay. Can. Good. So now, can you tell me what's the range, domain of f and range of f? Domain of G, range of G.
Domain of f is square bracket -1.5 positive infinity, and then range is square bracket -1.25 positive infinity.
Round bracket. Good.
The domain for G round bracket -1.25 comma positive infinity round bracket, and then the range is the same thing.
Yes. I forgot to put a minus sign here. -1. Yeah, same thing. Correct. Good. So which one? Is range of G subset of domain of f, or is it range of f subset of domain of G?
Give me
Confused? We draw number line. Consider the first case, Rg subset domain f. So we focus on Rg and domain of f. Rg tells me -1.25 to.
It's a subset.
Yeah, correct. Yes.
But for like RF and DG, I'm not sure because like they're the same.
Wait, hold on. Let me see. I designed it such that only one of them should be true. Let's just check it step by step. Range of G here is -1.25 to infinity, so empty circle. Then domain of f is what? -1.5 to infinity. So -1.5 is where? It's actually over here. Right?
Yeah.
Circle. Draw a line. This is df. Is it a subset? Yes. Okay, yes. So that means that which FG exists? Oh no, GF. Or is it GF? Or is it FG? I think it should be FG. Range of the inner function must be a subset of the domain of the outer function. So G is inner, F is outer. Okay?
Yeah.
Then let's check the other one. Is RF a subset of DG? Because they are equal, right? RF is what? -1.25 comma infinity. Domain of G is round bracket. They are not equal. Look carefully. Let's figure it out. Draw a number line. Okay. Then what is the RF and DG? It's here and here. There's a -1.25, and then infinity. So let's just label a -1.25 and an infinity, don't need to label. So let's figure out what is RF first. Square bracket -1.25 comma infinity. So that means you have to draw a circle around -1.25, shade or don't shade? Building RF.
Shade.
Shade in because it's a square bracket. Good. Now let's figure out the other guy, DG. DG is what? Round bracket -1.25 to infinity. So it will be the same thing, but with an empty circle. So question, is RF subset of DG?
No,
Fully contained within? No, why?
because DG is not
Can you
shaded.
give me one particular, what do you mean by, yes, correct, it's not shaded. When it's not shaded, it means that the solids, okay, when you say that RF is a subset of DG, it means that all values that are in RF must be inside DG. Can you give me one example of a value in RF that is not inside DG?
Negative 1.25.
The solid circle is not inside the empty circle. Okay, so that's why this is not true. No, this is not true. Okay, no. Understand?
Yeah.
So only one of them is. Yeah, I designed it so that only one of them should exist. Okay, so FG exists. What do we do now? We have to find the
Domain and range.
domain, range, and rule. Rule as well. So let's just go and find those functions. I'm trying to fit everything on one page. Okay, Ken. So let's just find the rule first. In this case, it's FG, right? I'm running out of space. Okay, I'll just write it over here. Sorry, I'm moving my working over here.
Okay.
F of G of X. Let's take a look at what it is. So it will be 0.2 times X minus 1 times X plus 4. But what is X? What is X? It's replaced with G of X. But G of X is still X. So it's the same function, okay? How about the domain of FG?
Domain of G, so it's round bracket negative 1.25 positive infinity.
Yes, you can copy and paste. If your handwriting is neat, then you write it like this in a table format. You just need to copy and paste. Copy and paste. Don't need to think already. Very fast one. Copy, paste. Okay, then after that, this is domain. What else we need?
Range.
Range. Okay, so let's find the RFG. How do we do that? Let's do the procedure. So first, the DF, you draw an arrow. Sorry, no. It'll be inner function G. DG, you pass into the inner function G, then you get the range of G. Then you pass into the outer function F, then you get the range of FG. So let's figure out step by step. What is DG again? Round bracket, negative 1.25, infinity. Pass it through G. What do you get as the range?
Negative 1.25 positive infinity.
Very good. So what you realize is, so what you should realize as you keep on doing all these examples is that the first step, DG and RG should always be the same. Copy, paste only. Now the part that requires more thinking is this part here. What does it mean when you take this guy, pass it into function F, and you get a corresponding range? It means that you are looking at the outer function F, which is F. Here is F. And then you consider if X is from this interval instead, from negative 1.25 to infinity, what will be the corresponding range? Listen carefully, it's X equals to negative 1.25 to infinity. Oh, by the way, this is not X comma Y, by the way. This is not X comma Y. Don't be confused with X comma Y. This means X starts from negative 1.25 and you go all the way to infinity. So let's look at the graph now. How do we represent that? Negative 1.25 comma infinity is actually from here. This is negative 1.5. So negative 1.25 is actually a larger value. It's over there. Can you see?
Yeah.
Then we are considering from that value, empty circle. Why empty circle? Because round bracket. And we go towards the right. Can you see my red color arrow?
Yeah.
Then you look at the corresponding graph. All these possible values. Or maybe I draw an arrow. Something like downwards, downwards, downwards at the point itself, upwards, upwards, upwards. Then you look at the graph. This is the relevant part of the graph. But what's the corresponding Y value? Let's see. When X equals negative 1.25, what's the corresponding Y value? It's just F of negative 1.25. Sub in X with negative 1.25. What do you get?
Let me calculate.
Yep.
Negative 1.2375.
Good. And then it goes upwards all the way, right? So it goes to positive infinity. Here, smallest is what? Minus 1.2375. Biggest is what? positive infinity in terms of the y coordinate. Is that clear?
Yeah.
Maybe you can think of it like there's a very big point here, then this is infinity. But don't write down infinity because technically it's not a number. So go from small to big. Then that's your answer already. The answer will be RFG will be negative 1.2375. Sorry, it's a bit light. Can you see?
Can see.
Comma infinity. Then infinity straight away, you know it's a round bracket, right? So round bracket. Then me increase
Left side also round bracket.
Also round bracket. Why? Because here empty circle, so that point is also not included. So negative 1.2375 is also not included, round bracket. Is it clearer now how to find range?
Yeah.
Okay, let's go on to our next example, example 3. Do you want to try on your own paper and pen?
Can. But I might take longer than you are.
Okay, just do it. You need a practice. It's fine. Okay, take out paper and pen, try this example.
Example 3, right?
Example 3. Fx equals to x. X is more than 3.5. Gx is x minus 1 times x minus 6. X is more than 3.5. Your goal is to find out Fg or Gf exists. Have you copied down the question? The two questions?
I haven't. I copied down now. I just drawing the graph right now.
Oh, okay. Okay.
Okay, I copy already.
Okay. I need to change my screen a bit. Here, here, and here. Oh, can see the screen?
Yeah, I can see.
Yeah. Just draw a graph too. Oh. So by now you have drawn the graph, right?
Yeah.
Okay. 3.5 enter. Oh, okay. It's not exact. Okay, I'll start drawing the graph as well on my end. Oh yeah, draw them on separate diagrams.
Yeah.
So it should be an empty circle, right? Because strictly more than.
Yeah, I got empty circle.
Then for the quadratic curve, it's just the bottom half.
Yeah.
I mean the right half.
Yeah, correct.
3.5 comma, what is the y coordinate? Negative 6.25. Y equal gx equals x minus 1, x minus 6. Okay. What's your domain of f? What's your range of f?
My domain of f is round bracket 3.5 positive infinity.
Round bracket as well. And okay, good. Range of f?
I got the same thing.
Good. All right. Well done. How about the domain G, range G?
Domain G round bracket 3.5 positive infinity, then range round bracket negative 6.25 comma positive infinity. But
Okay. Good. Sorry.
My y is different value from yours. I think I got mine. Oh no, mine is correct. Negative 6.25.
Okay. Yeah, my GC here, I think I got the same value. Let me type it again. 3.5, enter. I got y equals negative 6.25.
Oh, I saw it's negative 0.25. Sorry.
Okay, it's a bit too small. Okay, next time I try to
It's okay. It's okay.
figure out how to make it bigger. Okay, don't worry. So now how to proceed? Which one exists? Yeah, I'll put it side by side.
Exists.
GF exists. So you're saying range of F subset of domain of G, therefore what is it? GF? Is it GF? Yes, GF exists. Let's double check first. Range of F is what? This guy, 3.5 to infinity. Domain of G is what? 3.5 to infinity. They are the same thing. Can they be subset? Yes, they can be subset. So this is true. Yes. Good. How about the other way around? Range of G subset domain F. Is this guy subset of that guy? No.
No.
Because negative 6.25 to infinity includes negative numbers, and it cannot be contained inside this 3.5 to infinity. It's only positive numbers. You cannot contain negative numbers. So that's why this is not a subset. Not a subset. Okay? Good. So GF exists. What do you do next? What's your rule? G bracket F bracket X.
It's the same as G bracket X minus 1 bracket X minus 6.
Yeah. Good. Okay. So that means it's just x minus 1, x minus 6. Then what coincidentally, because I'm giving you an easy question. Then how about the domain of GF?
Domain domain of F bracket 3.5 comma positive infinity.
Correct. Good. How about the range?
I haven't found yet. I'm still finding that one.
Okay, draw the diagram. Draw the diagram, this diagram. And then maybe you take a photo and send me, then I give some comments.
Okay.
Once you're done, the last part.
Okay.
Yeah. Running out of space. Inner function in this case is f. Oh, I need to change the letters. Inner function is f. So df_rf. Outer function g, so rgf.
I did it on pencil though, so like it might be kind of light.
Okay. Oh, you sent it already?
I'm gonna send now. I'm taking a picture.
Okay. Let me.
Okay, I sent it again.
Okay, let's take a look. What do you have? DF is 3.5 comma infinity round bracket both. RF is 3.5 comma infinity round bracket both. Then range of GF, you just sub in the same domain inside, then you get back the same range. Okay, good. Negative 6.25 comma infinity round bracket. Perfect. Okay, so now since you already know how to do this question, right? The tutorial EJC one. Would you like to retry all the questions?
Okay.
Because it's not very well done.
Okay.
Yeah, it's the same procedure, 1 to 3. Okay, then maybe in addition to those questions that you redo, since you're redoing it, it should be a bit faster, right? I'm gonna give you some extra questions as well. Let me set up my screen first. Hold on a second. Resume share. Okay, can. Yeah. So anyways, yeah, the range of GF, because the domain is the same, that's why this is not challenging. It's just the same. Negative 6.25 comma infinity. I'll just fill in the blank. Then later I send you the PDF. You can have a reference. So example 4, 5, 6, 7. I'll just go through. I'll just let you try as practice. Okay. Or maybe should I go through one? Okay, I think I'll go through example 6. Example 6 is a bit funny. Look at example 6. I need more space. Example 6. Go through. So let's take a look at example 6. We have two functions, fx equal cosine x and gx equal square root 9 minus x squared. They tell you that fx equals to, sorry, for fx function, the domain is x and element of all real numbers positive. So don't include negative, don't include 0. Then gx will be 0 less than equal x less than 3. So can you tell me what's so special about this graph? If you let y equals to this square root 9 minus x squared, what's that equal to? What is this really equal to? Very confusing, got square. How about if I square both sides? If I square both sides, I would get y squared equals 9 minus x squared.
Oh, then it's 3 minus x.
Before using, you see this straight away, what do you get? Something square, something square. What shape is this?
Circle.
Circle, very good. Yes, 1 y squared plus 1 x squared is a circle. Of radius?
3.
3. Center is?
0, 0.
So without using a GC, you can draw the graph already. Okay. So it's a circle of radius 3, maybe something like this. 3 minus 3, 3 minus 3. But this is wrong. Do you know why or not? Because a circle, is it a function?
No.
Line. It's not a function. But here, when we give you a function, I tell you it is a function. Means that you must pass vertical line test. Can you see that it's either the top half that passes the vertical line test or the bottom half that passes? So in this case, actually, since we are looking at positive square root, right, it's actually just the top half. So let me just clean out my diagram. It should be this guy. But more specifically, look at the domain. 0 less than equal x less than 3. So must include 0, exclude 3. What does it mean? X equal to 0 is over here. You'll get a corresponding.
Remove the left-hand side.
Yes, correct. So remove left-hand side. How about this point and this point? Which one should be empty circle?
Empty
This
circle
point
is the 3.
Both are 3. Sorry. Let's
I
just
mean the x equals
let's
3.
call this A. Let's call this B. A should be point A here should be empty or empty or solid.
Solid.
Good. Then B should be
Empty.
good. Okay, understand already. Well done. That is your g of x. If you try to use a GC, let me show you. You won't get such a nice graph. It won't look so nice. They have problems with square root, I think, especially for circle. You see the graph, if I just zoom in, I'm using the highest quality already. I'm not cheating here. Move to the right, move down, then zoom in. You see, the graph is getting closer and closer to 3, but then it suddenly cuts off. Can you see that? There's a gap. That's because of the limitations of GC. They are not able to calculate values that are so close to infinity, so close to 0. So you need to know that it is a circle, then you should just go all the way to 3. There is no asymptote here. All right, Ken. So anyways, G is done. How about F? F, easy, cosine graph, just draw only. So I'm just gonna go through how to draw. Just remember cosine is down, down, up, up. All right, then you get all positive real numbers. So you just start from the x equal to 0 and you move to the right. And you draw multiple copies. Just draw another copy to remind ourselves it goes on all the way. Now take note, x element of R plus means you only start from positive. So this point here, positive excludes 0. So here should be empty circle. Right, x equal to 0 is not included. Is that okay?
Okay.
Okay, good. So now this is y equal cosine x. What is the value here, by the way?
1 and -1.
1 here, negative. Okay, so now we have our fx and gx. Let's try to figure out our domain and range. df, rf, dg, rg. df is all positive, so 0, infinity, round bracket, round bracket. rf, even though at the beginning here we don't include a 1, but eventually as we go on, do we hit a 1? 0, let's say this is 2 pi, 1.
Yeah.
Do we hit 1? Yes, right? So that means the 1 is still included. So what's your range of f now? All possible.
Square bracket -1, 1 square bracket.
Well done. Very good. DG?
Round bracket 0. A square bracket 0, 3 round bracket, and then
think carefully. This point here is 3, 0. That point there, point A is 0, 3. What's your smallest y? What's your biggest y?
0, round bracket 0, 3 square bracket.
Well done. Very good. You understand already. Okay?
Okay.
You didn't get tricked. I put square and round. You didn't put square and round again. You know how to read off the y coordinates. Empty circle means you exclude, so round bracket. Square, solid circle means you put square bracket. Finally get it. Very good, very good. Okay. Then now we continue. Now we want to find out which function, which composite function exists. Is it fg or is it gf? So we check, is Rg subset of domain of f or is it Rf subset of domain of g?
Rg subset of domain of f.
Yes, then the other one is false. 0, 3 is inside 0, infinity. You don't even need to care whether it's exclude 3 or include 3. Both cases are still inside 0, infinity. 0, infinity goes all the way. 0 to 3 only stop somewhere here. Oh?
Okay.
Yeah, so that's why, yes. But the RF is not a subset of domain of G because here -1 to 1 includes a -1 to includes -1, includes -0.9, includes -0.8, so on and so forth, which is not inside the region here, 0 to 3. Okay, good. So that means that we have which function exists? FG or GF?
GF. Actually, we have
Range of inner
FG.
subset domain outer. So we always phrase it as outer of inner of X. So in this case, yeah, it should be FG. Okay, FG exists. Is this part clear? F is outer, G is inner.
Yeah.
This one, you must get it right. Like, you only got 50-50 chance of getting it right. Flip a coin, I guess. Don't flip a coin, please. Please remember this rule. R of inner subset domain of outer. Then okay, so now we find the rule. F of G of X. What would it be? Cosine of
cosine of square root 9 minus x squared.
exactly. Good. So now how to find the domain of FG? Equals
Domain of FG equals to d no d dg
yes.
then arrow FG then
No. Find domain first. Domain first. Slowly. We find the domain first. Or in other words, you put down over here x more than 0. Same thing.
Okay.
Then you now this is called the rule. This is called the domain. Then now we find the range, which is the arrow thing. So the inner function first, arrow inner function, range of inner function, arrow outer function, range of outer inner function. Compose it. Fill in the blank. We already know DG and RG. So it's right over here. Huh? So copy and paste. Copy, then I paste. Drag it to the correct side. Here and there. Equal. Then this is the only part that you need to think about. Right?
Okay, I do the calculation.
Good. Yes.
Mm-hmm.
Need to calculate. Just look at the graph.
Wait, oh my god, I'm lost here.
Okay, I copy down the graph of G for you.
Okay.
Over here. So we currently have a composite function fg, and there's an inner function g, outer function f. So how do you get the range of the fg? You need to go step by step from the inner to the outer. Start with the inner function g. Get the domain. Pass it into the inner function, then you get the corresponding range of g. So maybe sorry, I realized I did it wrongly. I shouldn't be looking at G, I should be looking at F, right?
Yeah.
You need a calculation. Sorry, I'm confused.
It's okay.
Then after that, with this range of this with this range of G, you treat it as the new domain of F. Yes, then you pass it into this function F. So it goes from 0 to 3. Pi is around 3.14. So somewhere to the left. If you want exact value, actually, you don't need to calculate the decimal. Just cosine 3 is fine, right?
Yeah.
Cosine 3. Then when it's 0 is It's 1. It's 1. So what's the range?
Cosine 3, 1.
Yes. But then now you fill in the bracket.
Can I see like the value, like the
Cosine 3, you must use radians. It's negative 0.989999.
no, as in like, is there like a requirement for the X thingy?
The X thingy? Sorry, what do you mean?
Cause I forget the previous bracket. Wait, as in like, can I see the whole question? Like, can you zoom out? Range round bracket, square bracket.
Round bracket, square bracket. Let me see. You are including 3, but you exclude 0. You include 3.
I include 3.
So what about cosine 3? If 3 is included, it's cosine 3.
Yeah, cosine 3 is included. Square bracket, then round bracket.
Much better. Yes, correct. Okay, understand now?
Yeah.
Still a bit iffy. Yeah. So when you include, it's a square. When you exclude, it's a round. But you must read the graph. Here, our new domain is 0, 3, exclude 0, include 3. If we do not include 0, we look at the graph. When x equal to 0 here, maybe I draw a bigger graph. It will be more obvious, I guess. When x equals to 0, we look up on the graph and then we reach 1. But here we exclude 0, so it is an empty circle, empty circle. Then we include x equal to 3. So here is 3. Oh, sorry. Here is 3. We go down to the graph and then we look at the corresponding y coordinate, which is our cosine of 3. This is approximately negative 0.989. Then this value, do we include? Yes, we include. Why? Because here we include x equal to 3. So it should be a solid circle, which means the y cosine 3 will also be solid circle. So now you see it goes from cosine 3 solid circle to 1 empty circle. So it goes from cosine 3, 1, cosine 3, 1.
Okay.
Empty circle, round, solid circle, square. That's how you get the answer.
Okay.
Yeah. Okay, good. Do I have time for any more? Let me take a look at the EJC tutorial. Did I send you the solution already?
Yeah, you sent me the whole thing.
Yeah, okay. The solution as well?
Yeah.
Okay, good. Yes. Just go and see the question. You should, I recommend you to redo the entire question 1 to 3.
Okay, then do I do like 4 to the 8?
4 to 8. Should you try? Maybe do I have time? How much time do I have left?
As you want to try now?
Yes.
Because I think I need to go for lunch soon. That's why.
Oh, okay.
But I can try to do like question 4 to 8 this week, because like I think this week I have more time compared to like the last week.
Okay. Can. You should try it. Yes.
Then you're the example you want me to try also?
Yes, I'll send you the examples later.
Okay, then if like whatever I don't manage to complete, then I just tell you again, right?
Can. Yeah. Just try whatever you can. Maybe for now, don't do question 9. No. Let me see again. Don't do question 10. Question 10 involves this periodic function, which I have yet to elaborate on. Wow, this one another time-consuming thing. Yeah, just do question 1 to question 9 and the extra examples. Is that okay?
Can. Then is there any like in order that which one I should do first? Like which one you think is more important for me to do first?
Let me see.
Like should I just get my basics right first and do like your example and 1 to 3 first?
Correct. Yeah, actually that's true. Okay, I'll give it to you later. I'll list it down. What number 1 should be your highest priority, then number 2, then number 3.
Okay,
I'll list it
okay.
down for you. Then that's all for today. If not,
Okay,
you
can.
rush off. Okay,
Sorry,
can.
yeah.
No worries. It's okay.
Thank you so much.
Thank you. Thank you. Bye bye.
Yes. Anyways, now I'm like going to move on into vector soon, but like I haven't like learned finish everything yet. So like I don't need to do anything about that yet, right?
What do you mean by do anything?
Like I haven't watched finish the tutorial. I also haven't. I mean, I haven't watched finish the lecture. I also haven't started the tutorial.
Your school hasn't started tutorial yet.
Hasn't like going to start soon already. But
Okay.
like, I think I can do first. Yeah, we can still do functions first.
Okay, we continue with functions because your functions quite weak.
Yeah, it's very weak.
Yeah. So then what is it? The video, right? I mean, you can watch it. It's extra lah. You can watch it on your own time, own target. I'm sure your school would have.
Right?
Yeah, I'm sure your school would have already covered it because they understand that.
My school lectures are not that good. Like they don't cover it that well.
I don't know about your school. Yeah, but if you have time, you go and watch the video. If not, it's optional lah. I mean.
Okay,
yeah.
okay, I'll watch it.
Yep. Okay.
Okay, okay. Thank you.
Thanks. Oh yeah, yes, the book, the Zack Chen one. Try buying it from Popular.
Oh, okay. I didn't have time to go Popular this week. I'll buy. Like thanks for the reminder.
Thank you. I'll send in the group chat. That's all for today. I'll send you the video link as well.
Okay, can.
Bye bye.
Bye bye. Thank you.